We'll slide the science guys. We'll slide the science guys. Will, slide, slide, slide. We'll slide the science guys. Physics rules. We'll slide the science guy. Inertia is a property of matter. We'll slide the science guys. Will, slide, 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 slide. We'll slide the science guys.
So before our featured movie, here's a little bit about the history of projectile motion. It was Galileo who first accurately described projectile motion. He showed that it could be understood by analyzing the horizontal and vertical components separately. No one had done this prior to Galileo. This illustration reflects the general opinion before Galileo, which followed largely Aristotelian lines, but incorporating a larger theory of impetus, which maintained that an object shot from a cannon, for example, followed a straight line until it lost its impetus, at which point it abruptly fell to the ground. Later, simply by more careful observation, as this illustration from a work by Niccolò Tartaglia shows, it was realized that projectiles actually follow a curved path. Yet no one knew what that path was until Galileo. There was yet another brilliant insight that led Galileo to his most astounding conclusion about projectile motion. First of all, he reasoned that a projectile is not only influenced by one motion, but by two. The motion that acts vertically is the force of gravity, and this pulls an object towards the Earth at 9.8 meters per second squared. But while gravity has pulled the object down, the projectile is also moving forward, horizontally at the same time. And this horizontal motion is uniform and constant according to Galileo's principle of inertia. He was indeed able to show that a projectile is controlled by two independent motions, and these work together to create a precise mathematical curve. He actually found that the curve has an exact mathematical shape, a shape that the Greeks had already studied and called the parabola. The conclusion that Galileo reached was the path of any projectile is a parabola. Characteristics of projectiles. There are two types, the horizontally launched projectiles and the non-horizontally launched projectiles. For the horizontally launched projectiles, once the object leaves the table, it experiences a downward acceleration equal to gravity. Thus, the vertical velocity, denoted by Vy, is continually increasing. The horizontal velocity, Vx, remains constant and is equal to Vxo. The two vectors Vx and Vy are added together to get the velocity at each point on the path. For the non-horizontally launched projectiles, if an object is pointed at any angle, the motion is essentially the same except that there is now an initial vertical velocity, Vyo. Because of the downward acceleration of gravity, Vy continually decreases until it reaches its highest point, at which it begins to fall downward. So now let's go to Will and Sly, the science guys, who are experts at projectiles.
Hi, I'm Will.
I'm Sly.
And we're Will and Sly, the science guys.
And we're here today talking about projectile motion. Projectile motion can best be described as an object moving through the air in a parabolic path. Just think of a basketball being thrown by your arm.
You're cool.
So what's left to affect it? Air resistance. You can think of air as really, really thin water. So thin that you can't even see it. Air works the same way. Lucky for us, we're working with ideal projectile motion, which means we can assume air resistance, among other things, to be negligible.
Ah, negligible. A physics student's favorite word.
According to the fundamental laws of physics, the basketball and the golf ball will fall at an acceleration of 9.8 meters per second squared.
No doubt.
So, audience, what do you think? Will the basketball or the golf ball fall faster?
The basketball. Let's see. Wrong.
So you see, objects in free fall will always fall at an acceleration of 9.8 meters per second. So, regardless of their weight, they will always fall at the same time.
I still don't believe you.
You still don't believe us, huh? Well, let's do another experiment. Which tennis ball do you think will fall to the ground faster?
The first one. Let's see.
the tennis balls fell at the same exact time because the law never changes. Acceleration is always 9.8 meters per second squared. So regardless of how big the balls are, like we saw before, the ball will always fall at the same time because of gravity.
Okay. Some equations for ideal projectile motion are...
To figure out how long the ball will be in the air, you can use the equation distance equals initial velocity times time, plus half the acceleration multiplied by time squared. Then you set the left side to 0 and factor the right side to get the time. Don't forget that if you're dealing with vertically launched projectiles, you must calculate initial velocities for both the horizontal and the vertical component.
To figure out horizontal displacement, it is as simple as using D equals VT.
For impact velocity, for vertically launched projectile, you should find the hypotenuse of your triangle, but don't forget to find the angle that it was launched at, and you can find it using tan.
To find the max height, you must use the equation VF squared equals VI squared plus 2AD. VF is always 0 because at the max height you are changing directions. It's like a transition point. And remember, when finding vertical velocity, you must always use the vertical components. Now that we have an understanding of what happens during ideal projectile motion, let's go out and actually put this into practice.
Jimmy, eat your potato skin. No! Jimmy, eat your potato skin. It's good for you. No! Jimmy, I'll take away your yo-yo! No!
At each moment that the ball is in the air following some path, it moves up some vertical distance, and it moves over some horizontal distance. Think of it as dissecting the ball's motion along the arc.
It has some vertical component of the velocity pushing it upwards,
And some horizontal component pushing it forward.
so when the ball is hit, it has some initial velocity that can be separated into a horizontal and vertical component.
And as the ball moves through the air along the arc, gravity is pulling against the vertical velocity.
It begins to move upwards less and less until it reaches its highest point.
And after that, the ball begins to move back to the ground.
But remember, while this battle is going on, the ball is still moving forward. It is important to understand that gravity does not affect the horizontal component of velocity.
So, thanks for joining us on Will and Sly the Science Guys.
Oh look, a jungle gem!
Now that we have an understanding of what happens during ideal projectile motion, let's go out and practice. Now that we have an understanding of what happens, now that we have an understanding of what happens during now that we have an understanding of now that we have an understanding okay. Now that we have an understanding of what happens during now that we have an understanding of what happens during ideal projectile motion, let's go out and actually put this to practice. Now that we have an understanding of what happens during ideal projectile now that we have an understanding now that we have